Bismillah ar-Rahman ar-Rahim. We'll continue doing 4.4. Okay. We finished 27. That was the last things we did. So now let me continue. 28. What are we doing in these questions? We are finding the points of inflection and the concavity. Okay. So we are talking about the second derivative in general. Okay. So in each case, you need to find the second derivative. F of x equals sine x plus cosine x. Domain is this. This is domain given on us. So I have f prime is what? Cosine minus sine. F double prime will be minus sine minus cosine. Okay. This is differentiable continuous. You have nothing to worry about. So I have f double prime equals 0. F double prime always exists. So that implies I have what? Sine x equal minus cosine x. So sine are the same except with the sign, except they're equal to each other. The difference is only the sign. So that of happened where second and fourth quadrants, and we have only one cycle. Okay, so I have this one happened at x equal what? 3 pi over 4. I know the reference angle is pi over 4. Second quadrant and fourth quadrant, 7 pi over 4. Okay, so I'll make the test intervals. This is 0. This is 3 pi over 4. This is 7 pi over 4. This is 2 pi. I have to check this function. This is the function I'm dealing with. I take pi over 2. It will be minus 1, 0. So that will be negative. 23 pi over 4, 7 pi over 4. Take, for example, pi. Will be 0 plus 1. That will be positive. Here it will be minus. Take any value. This is what? 315, 330 you take. This is 315, and this is 360. Huh? We did something similar before. So find an angle between them, 330, you can get it. Okay, so it's concave up, concave down, I mean, from 0 to 3 pi over 4, and 7 pi over 4 to 2 pi, concave up, 3 pi over 4 to 7 pi over 4. Is there any point of inflection? Yes. These two are points. This is an inflection point, and this is an inflection point. So I have inflection point at x equals 3 pi over 4, and at x equals 7 pi over 4. Okay. Let me go to the next one. 29. The only difference that now the calculation becomes more complicated. That's the only change. Yeah. Actually, we cannot do 29 because it needs a calculator where we need to solve. Yeah, it needs a calculator, so I will not do it 29. You need a calculator to do it. I will do 30. There's no need for the calculator. By the way, 29 is the same idea, but the calculations, you need to deal with the calculations. You need to differentiate this sine to x. But at the end, you need to solve an equation where you need the calculator to do it. So I will not do this 29. 30, f of x plus 2 cosine x. He gave us this interval. Okay. So f prime will be 1 minus 2 sine x. F double prime will be what? It will be minus 2 cosine x. Easy one. So I have f double prime equals 0. That implies what? Cosine x equals 0, which is happening where? X equal pi over 2 or x equals 3 pi over 2. Okay. So this number 9, this test intervals, I have 0, pi over 2, this is 3 pi over 2, this is 2 pi. I'm checking this function with the minus sign. Be careful with the calculation. 0 to pi over 4, take pi over 4. Quadrant. This is the first quadrant, so cosine is positive, times this minus, that will be negative. This is pi over 2 to 3 pi over 2. It will be what? Cosine is negative, so that will be positive. Cosine times minus, or it's going to take pi, it will be minus 1. That's very clear. And here it will be negative, fourth quadrant. Positive times negative, that will be negative. So it's concave down from 0 to pi over 2, and 3 pi over 2 to 2 pi. Concave up from pi over 2 to 3 pi over 2. Inflection point, yes. Inflection point here and there. At x equal pi over 2. And at x equals 3 pi over 2. Okay, next one. This is 30, 31. Now we have exponential function. Okay. Y equal e minus 3 over x. Okay. We'll do the same. By the way, what is the domain now? In this section, in this example, or in this exercise, in this case, I have the domain all real numbers except 0. Because the function is not defined at x equals 0. So we'll find y prime. It will be e minus 3 over x times derivative of this, which is 3 over x squared. Okay. Now we need to find y double prime. It's a product of two functions. Yeah. So I have y double prime. Derivative of the first is minus 3 over x times 3 over x squared times the second, plus is minus 3 over x times derivative of this. What's the derivative of this? 3 over x squared, 3x minus 2. So it will be minus 6 over x cubed. Okay, I can take is minus 3 over x common factor. Not only that, over x to the power 4 also. What's the remaining? I have 9. Here I have what? Minus 6x. I have 9. Yes, minus 6x. So that will be my function, y double prime. I have y double prime equals 0. Will give me x equal what? 9 over 6. Is it the domain of f? Yes. And when I make 9 over 6, and who, yeah, 3 over 2 actually. Yeah. I divide by 3, that will be 3 over 2. Belongs to the domain of f. Okay. So when I do, also I have here point of discontinuity at x equals 0. So when I do this, I will do 0 and 3 over 2. Okay. So take a value. This is my function. This is positive. This is positive. So that my big concern is here. So before 0, take a negative value, be positive. between 0 and 3 over 2. Also, that will be positive. This one will be negative. So it's concave up from minus infinity to 0 and 0 to 3 over 2. I cannot say from minus infinity to 3 over 2 because the function is not defined at 0. Concave down from 3 over 2 to infinity. Inflection point, we have only one inflection point. Inflection point at x equals 3 over 2. Okay. Find the space for more problems. Okay. 32. Y equal half ex minus es minus x. By the way, this function will define it in section 5.9. This is called sine hyperbolic. We'll deal with it in 5.9. Okay. Now we'll do y prime. Y prime will be what? Half ex plus es minus x. By the way, this is also called cosine hyperbolic. This is, we'll do it in section 5.9, the same thing. That will be half ax minus es minus x. Okay, now I need to solve this. By the way, the domain is all real numbers. Function is defined everywhere. We have no problems. So I'm getting what? Ax equal es minus x. In other words, take ln x equal minus x. So that means x equals 0. That's the only solution. Okay. Now we'll do what? Yeah. Now we'll do the sign diagram. I have only 0. This is 0. This is my function. Take a value before 0. For example, take for example, I can do the trick. Take 1, for example. 1, a minus 1. See, is minus 1 minus e. We know that 1 over e is less than e, so that will be, you get it, f of, let me do it with 1. 1 will be half e minus 1 over e. E is minus 1, so that will be positive. But when I deal with f minus 1, let's here half 1 over e minus e, and that is negative. So it's a negative and this is positive. So it will be concave down from minus infinity to 0. And concave up. Concave up from 0 to infinity. And I have inflection point at x equals 0. By the way, the inflection point is 0 and 0. Huh? We substitute, you get 0 and 0. You can put it as a point, 0 and 0. Yeah, always you can find the y values. Okay, 33. Y equal x minus ln x. As you notice, the idea is the same, but now we are doing different functions. What's the domain here? From 0 to infinity. Open. Okay, y prime, 1 minus 1 over x. Y double prime will be what? 1 over x squared. Notice one thing. This is always positive. So that means what? The function is concave up in its domain. Which is 0 to infinity. Is there a point of inflection? No change of concavity, so there is no point of inflection. No inflection point. Okay, nice one. 34. As you notice, we are doing the same thing, but now different functions. Huh? Then square root x squared plus 9. Okay, this one I can rewrite it as half ln x squared plus 9. Okay, find y prime. Y prime will be what? This is over x squared plus 9. Don't forget the half. I have 2x. So it will be x over x squared plus 9. Find the second derivative. We are concerned about the second derivative. So it will be y double prime. Quotient rule. I have 1 times x squared plus 9 minus 2x times x all over x squared plus 9 square. And that will be what? That will be 9 minus x squared. Okay. Y double prime equals 0. By the way, it's the domain or real numbers, huh? Domain R, huh? Because it is always positive. Yeah, it cannot be 0 actually. Okay, so I have x equal plus or minus 3. Very clear. 9 minus x squared equal to 0, which is x equal plus or minus 3. So I plug this. I have minus 3, and I have 3. Take a value. This is my y double prime. You notice this is always positive. So my concern is this one. So before minus 3, take minus 4. That will be negative. That will be positive. That will be negative. So let's concave down. Minus infinity to minus 3. And 3 to infinity. Concave up. Minus 3 and 3. I have inflection point at x equals minus 3 and at x equal 3. Okay, that will be 34. 35. Arc sine x to the power 4 over 5. 35. Y equal arc sine x to the power what? 4 over 5. Yeah, by the way, what's the domain of this? I know for arc sine, the domain is minus 1 to 1. This is my domain. I need to do the calculation now. Yeah, it seems the calculation a little bit complicated. Y prime will be what? I think it means that will be 1 over square root 1 minus this squared times this derivative, which is 4 over 5, x is minus 1 over 5. In other words, that will be what? Yeah, you need to rationalize it. No need. I have 4 over 5, x is 1 over 5, square root 1 minus x to the power 8 over 5. That will be y prime. Okay. Y double prime or f prime, f double prime, y double prime. Yeah, it's a little bit complicated, but this is the answer. 20x 8 over 5 minus 4. Yeah, very complicated problem. 25 x 6 over 5 1 minus x to the power 8 over 5 to the power 3 over 2. Believe me, this is the answer, which is not easy to do. But assume the question is, this is y prime, this is y double prime. Find concavity and find all of these things. Okay. So if double prime equals 0 or y prime equals 0, y double prime, it depends you write it y or f prime. You have what? Yeah, you have complicated things. We have 4, not 4, 20 x 8 over 5 is equal to 4. That means x to the power 8 over 5 equal 1 over 5. So that means x equal 1 over 5 to the power 8 over 5. This is for sure less than 1. So it's in the domain of f. Okay. And I have y double prime does not exist. If what? If x equals 0 or x equal 1. 1 is a borderline, so no need to worry about it. So I have minus 1. I have 0. I have this number, strange number. And I have 1. And this is my function. Okay. Take a value minus 2. I'll give you what? I'll give you negative there. And negative here also. Oh, no, positive. No, not minus 2, minus half, for example. Minus half. That will be positive, huh? That will be positive. No, that will be what? Minus half to the power 8. Yeah, that will be negative. And that will be positive. That will be, wait a minute, minus half. This one will be positive. This one will be positive, and this one will be positive. Yeah, because this is 20. So this will be positive. Between 0 and this, since this is the zeros, still this is positive, but this will be a big number, correct? No. Yeah, by the way, I have here plus or minus, sorry. That will be plus or minus. Yeah, that okay, okay. No, because this is even power. So that will be plus or minus. Yeah, I don't think this is a good question to do. But it needs calculator for sure. That will be minus 1 over 5, 8 over 5. And this is 0. And then I have 1 over 5. And this is 1. This is plus. Now this will be negative, since this will change sign. But at 0 will not change sign, because this is always positive. So this is minus, this is plus. Okay. Let's concave up from minus 1 to this strange number. And from this to 1. And concave down from minus 1 over 5 to the power 8 over 5 to 0. And 0 to 1 over 5. Inflection point. We have it at here and in this one and that one, because there is a change of concavity. It will be plus or minus. This is the range. Yeah, the numbers are not nice ones. Okay. I have 36. Hopefully it's not arc down x square. Yeah, this one is a little bit better. Yeah, so we'll do y prime will be 1 plus x square derivative of this, which is 2x. Nice one. Now I can do y double prime. What do you want? 2, 1 plus x to the power 4 minus 4x cubed times 2x over this square. By the way, the domain are real numbers, huh? Very clear, the domain is all real numbers. Actually, arctan is defined everywhere. Okay. So that give me what? I have 8x to the power 4 minus 8, so it will be 2 minus 6x to the power 4 over this. In other words, 2, 1 minus 3x to the power 4 over this. This is always positive, so no need to worry about it. So I have y double prime equals 0. So I need to solve this. So I have x to the power 4 equal 1 over 3. So I have x equal what? Plus or minus the fourth root of 1 over 3. Which is the value between, yeah, between 0 and 1. The positive, the negative part between minus 1 and 0. Okay, so I will put the number. I have, this is the number. I have the negative 1. I have the positive 1. Take a value less than this, take minus 1, for example. Will give me what? Will give me negative. Take 0 between these two. I have positive. Take 1, I have negative. So let's concave down from minus infinity to this strange number and concave and this interval. هذا السؤال شوية معقول أكثر من اللي قبله. The numbers are still easy to deal with. And they have inflection point at these 2 points. Okay, that 36. Yeah, we are done with this complicated. Well, I need to find the y double prime and discuss the concavity and inflection point. Okay, now he's asking about the second derivative test. Only I want to do the second derivative test to find the relative maximum, relative minimum. So I need to find the critical numbers or f prime equals 0, and then I will do the calculations. Then I will check if double prime positive or negative. If it is 0, test fail, and I will not do it. 38. 38, I have f prime. Let me write f of x. Let's start with polynomials, easy ones. F prime minus 3x squared plus 14x minus 15. And that is, if you factor it, you get this. So this is minus 15, minus 9, minus 5, minus 14 times the minus 14, 3x squared minus 3x squared. So critical numbers, I have x equals 3, or x equals 3/5. Let me check f double prime. F double prime will be what? Easy ones. Minus 6x plus 14. Okay. So I will check f double prime at 3 will be what? It will be negative. I don't care. Minus. I care only as negative or positive. So you have local max at x equals 3. F double prime of 3/5. Yeah, that will be minus 18/5. For sure, it's less than 14. So that will be positive. So you have local min at x equals 3. That's what we will do for many problems. Yeah. Wow. Why is this? It's too much problems. It's okay. I try to do them as quick as possible. Okay, 40. What is f of x? Minus x to the power 4 plus 2x cubed plus 8x. I'll do f prime. That will be what? Minus 4x cubed plus 6x squared plus 8. Yeah. Actually, this will be factored using the. You need to notice, 2 is a root, and then you can factor it using the rational zero theorem. Or you just divide by x minus 2, you get the rest. Okay. This one cannot be 0. So you have critical number x equal to. The difficulty is to factor this, but you need to figure out, 2 is a root, then you can do it. Okay. So now what is f double prime? F double prime will be minus 12x squared plus 12x. So you notice in f double prime at 2 will be what? Will be negative. So I have local maximum here. I don't care about the value. So I have local max at x. Okay. 45. Let me write it y at the same time. Cosine x minus x. Yeah, you should notice one thing quickly. Y prime will be what? Y prime will be minus sin x minus 1. Yeah, for sure, this is always will be less than or equal to 0. So the function is a decreasing function or non-increasing function. So there is no relative extreme. It is always negative. So it's always decreasing or constant, decreasing, non-increasing, let me say, non-increasing function. Or you can do it. So for sure, there will be no relative extreme. Or you can do it the wrong way. Find y double prime, check the, we'll find when sin x equal minus 1, find these angles, and then check y double prime. For sure, it will be 0. But the test will fail, so you can conclude. 46. Hopefully, I will not get complicated problems. I will check f prime will be what? 2 cosine x minus 2 sine 2x. To find the critical numbers, I need to solve this. When cosine x equal to cosine, I have 2 cosine x. I can write this as 4 sine cosine equals 0. Can take 2 cosine x common factor. I have 1 minus 2 sine x equal to 0. From this, cosine is, by the way, what's the interval? Between 0 and 2 pi. Okay. Cosine x equals 0. I have x equal pi over 2 and 3 pi over 2 from this one. Here I'm getting what? Sine equal half. That's first and second quadrant. Pi over 6 and 5 pi over 6. Oh, I need to check f double prime. F double prime will be what? Minus 2 sine x minus 4 cosine x. I check them one by one. F double prime at pi over 2. That will be minus 2. That will be 0. It will be no, that will be cosine pi, which is minus 1. So it will be minus 2. Be careful, huh? Minus 2 plus 4. That is 2 positive. So you have local minimum at x equal pi over 2. Okay. Check f double prime 5 pi over 6. We do the calculation. That will be cosine 10 pi over 6 and 5 pi over 3, which is 5 pi over 3. That will be fourth quadrant. This will be positive, negative, negative. So that gives me negative. To save time. I forget f double prime pi over 6. Huh? It will be also negative. Huh? Check them. Huh? Local max. And I have f double prime 3 pi over 2. That will be positive. Yeah. So, okay. Yeah, I leave the checking for you. But this is the idea. Okay, this is 46. I forget 41, 42. Let me do those ones. The same idea, but let me do it. If x is what? X is about 2 over 3 minus 3. And to check f prime, same idea. F prime. As I said, I'll concentrate only in the second derivative of this. When it's applied, it's not apply, I will stop. I will not do it. You notice here, that will be 2 over 3. X is minus 1 over 3. So it's 2 over 3, x is 1 over 3. There is a critical number, which comes from f prime does not exist, which is x equals 0. But you cannot do it. Second derivative test is not applicable. Is not applicable in this case. We need to do First derivative test. I will not do it. Okay. 41, 42. F of x square root x squared plus 1. I want to do this. What will be f prime? If we do the calculation, that will be 2. Here I have 2x. So it will be x over this. Where I have critical number coming from f prime equal to 0. So I have x equal to 0. Okay, second derivative. If we do the calculations, you're getting this. Which is always positive, by the way. So I have f double prime at 0 will be 1 positive. So I have local minimum at x equals 0. Okay, this 42. 43, x plus 4 over x. We'll do the derivative. The domain orient numbers except 0. F prime will be 1 minus 4 over x squared. In other words, x squared minus 4 over x squared. F double prime would be what? 8 over x cubed. From here, I have very clear critical numbers, x equal plus or minus 2. So I need to check f double prime at minus 2, which is negative, minus 1, so it's negative. So I have local max. F double prime at 2, positive, so I have local min. I can write at x equal to, at x equal minus 2. Okay. 44. If x equal 9x minus 1 over x plus 5. Okay. F of x, 9x minus 1 over x plus 5. Domain, orient numbers except minus 5. Okay. F prime will be what? Will be 9 times x plus 5 minus 9x minus 1 over x plus 5 square, and that will be 46 over this. So f prime equals 0, give me nothing. So we cannot apply no critical number, actually. No critical number. And also, if prime does not exist at x equal minus 5, is not a critical number. So this is going to be nothing. Cannot be. So no critical numbers. Also, if double, so no extreme, no relative extreme. And so no relative extreme. As we say, if there is a relative extrema, then for sure there should be a critical numbers. Is 2, 48. Yeah. F of x, x, then x. Okay. What will be f prime? F prime will be then derivative of x, then x plus 1. Critical numbers, I have then x plus 1 equal to 0. So I have then x equal minus 1. That means x equal is minus 1. By the way, it's the domain of f from 0 to infinity, which belongs to the domain of f. Okay, find f double prime will be what? 1 over x. So for sure, f double prime at e at 1 over e will be what? Will be positive. I don't care. Will be positive. Yeah. So that means we have local minimum at x equal 1. That's it. Okay. Because that I choose many problems because they are easy. But the thing is the space isn't the right one. Okay. X squared ln x over 4. This is 50. Y equal x squared ln x over 4. What will be the domain? What's the domain? From 0 to infinity. Open. Huh? Y prime will be product rule. Then give me what? X squared times 4 over x times 1 over 4 plus 2x ln x over 4. In other words, which is x times, this is cancelled, huh? It will be x, let me do it in 2 steps. X plus 2x ln x over 4. In other words, I can't take x as a common factor. The remaining is 1 plus 2 ln x over 4. Critical numbers, x equals 0. It's not in the domain, so out. I need to solve this. 1 plus 2. So I have ln x over 4 equal minus half. Take e both sides. You get what? X over 4 is minus half. That means x equal 4 is minus half. That will be the critical number. Check f double prime. What will be double prime? Yeah, you can do it from here. That will be, if we do the calculations, it will be what? You can do it from here better. X is 1, so this is 1 plus 2, then x over 4 plus x plus 2x, derivative of this, which is 1 over x. It's 4 over x times 1 over 4, so it's 1 over x. So the answer is 3. Okay. I check f double prime at this number. That give me what? That will be minus 1. That will be positive. That will be positive. So I have local minimum at, but this is strange number. Okay. G of x 52. Let's write the function. F of g of x 1 over root 2 pi. This is just a number. A minus x minus 3 squared over 2. Yeah, not easy, not difficult one, but writing it make it very complicated. That will be yeah, I need to do that. This is will be 1 E of this times derivative of this minus x or something. That will be minus x minus 3. Minus 2 over 2, so it's minus x minus 3 times. So the answer is minus so critical numbers. By the way, the domain is all in numbers, huh? Everything is okay. We have nothing to worry about. So critical numbers, I have x equals 3. Okay. We'll find g double prime. I will leave it for you. You will do it. You get this. 1 over root 2 pi times x minus 2 times x minus 4 e to this strange power. Okay, check g double prime as 3. It will be what? This will be positive, this will be negative, this is always positive, so it will be negative. So I have local maximum there. I have local maximum at x equals 3. Yeah. Now, let me do 54. I don't think I need all of this space. Let me do it here. Let me do it here. 54. Yeah. 54. I have f of x. X is minus x. What will be f prime? Is minus x plus x is minus x. Oh, with the minus sign. Minus x. Yeah, because e is minus x. That will be 1 minus x is minus x. The domain is all in numbers here, right? Critical numbers, x equal 1. Coming from f prime equals 0. We'll find f double prime. It will be is minus x at x minus 2. Very clear. If double prime at 1 will be what? Positive and negative. It will be negative. So I have local maximum at x equal. Easy one. 56. Yeah, with the log. Actually, I can rewrite the function, change it into len. I can do the calculation. I'll find my prime clearly. It will be something like this. You can check the calculation. By the way, the domain is what? From 0 to infinity. So I have critical number. If x equals 0, it's not in the domain, so ignore it. I have 2 ln x plus 1 equal to 0. So I have ln x equal minus half. So x equal is minus, which is in the domain. Check f double prime. If we do the calculations, you will get this, which is easy one. Now check y double prime at this strange number. You'll get what? Minus 1 plus 3 positive. That will be positive. So you have local minimum at this value. Yeah. It's 56, 58. Oops. Now we are dealing with arc sine. Y equal arc sine x minus 2x. What will be f prime? Y prime will be 1 over square root 1 minus x squared minus 2 to find critical numbers. I need to solve this equation, which is implies this equal to, which implies what? 1 minus x squared equal 1 over 4. So I have x squared equal 3 over 4. So I have x plus or minus square root 3 over 2. Okay, the domain is minus 1 to 1, huh? Because of arc sign. This belongs to the domain. Very clear. This done, yeah. Square root 3 over 2 is this done 1. So I'll find f double prime. F double prime, if you do the calculations, you get this. X, not difficult. Then you check f double prime as square root 3 over 2. That will be what? Positive. Here we have 1 minus 3 over 4, so it will be positive. I don't care about the number, so we have local min. If we check f double prime of minus square root 3 over 2, that will be negative, because this will be negative. Still, the denominator is positive. So we have local box. Yeah, okay. This is 58. I have 47. We are almost there. I have 47. I have y prime equals 16x minus 1 over x. Not that right. Okay, not fine. Let's check the critical numbers. I need to solve this equation. In other words, I have 16x squared minus 1 over x. By the way, what's the domain? From 0 to infinity. So this is will give you what? Equal to 0. So I have x squared equal 1 over 16. So I have x equal plus or minus 1 over 4. These are the critical numbers. And they belong to the domain. Not all of them. X equal 1 over 4 belongs to the domain of f, but does not belong to the domain of f. So this is okay as a critical number. This one is not. Okay. So the critical number, only x equal 1 over 4. Find f double prime. Is it easy one? Yeah, it will be 16 plus 1 over x squared, which is always positive. So it means I have local minimum at x equal 1. Okay. 49. What is the function? Y equal x over then x. By the way, it's the domain of this one. Be careful here. I need x is positive, and then x not equal to 0, which means x not equal to 1. So it's from 0 to 1, union 1 to infinity. That will be the domain of f. Okay. We'll find f prime, and I will give you the answer. It will be what? Derivative of the numerator, ln x minus x times 1 over x, which is minus 1 over ln x squared. Okay. So critical numbers means ln x minus 1 equal 0. So that means x equal e. Is the critical? Is it the domain of f? Yes, it's the domain of f. F double prime will be what? Yeah, if we do the calculation, you will get this 2 minus ln x over x ln x. Check f double prime at e. That will be 2 minus 1, which is positive. E times that will be positive. Check the sign. I don't care what is the value. So I have local minimum at x equal e. Okay. This is 49, yeah. 51 y equal ax plus es minus x over 2. Y prime would be what? Ax minus es minus x over 2. So to find the critical numbers, I need to solve this equation. Ax minus ax over 2 equals 0. So ax minus es minus x equals 0. Multiply by ex, you will have e2x minus 1 equal to 0. So you have e2x equal 1. Take ln, you have 2x equals 0, so you have x equals 0, which is belongs to the domain. The domain is all real numbers. Okay, f double prime, you will get what? Ax plus e minus x over 2. Y double prime at 0, you have what? 1, which is positive, so you have local minimum at x equals 0. Okay. Now, 53. Yeah, I'm doing different functions only. Yeah, but I think we are enjoying the calculations. X squared is minus x to practice the calculation. We'll do f prime. That will be what? 2x minus x squared. The domain is all real numbers here, huh? So that will be 2x minus x squared is minus x. Critical numbers comes from where? Comes from 2x minus x squared, which is x2 minus x equals 0. So you have x equals 0 or x equal to. We'll find f double prime. Not difficult, let me do it. That will be 2 minus 2x is minus x plus 2x minus x squared minus a is minus x. And that would give me what? Is minus x. I have x squared minus 4x plus 2. Now check if x equals 0. Check f double prime at 0. That will be positive. Okay. Means local minimum. X equal to. What will be f double prime at 2? That will be positive. 4 plus 2 minus 8. That will be negative. So I have local x. Okay. This is 53. Let me do 55. 55. Y equal 8x 4 minus x. What will be f prime? It will be 8 4 minus x plus 8x. What's the derivative of this? It will be 4 minus x times ln 4 times minus 1. So I can take 8 x with the minus sign. Let me take it with the minus sign. Make the calculation easier. Minus 8, 4 to the power minus x. This is my common factor. I have here minus, so I have x ln 4. Huh? I have x ln 4 minus 1. Okay. This is 4 minus x. Critical numbers. I have f prime equal to 0. So I need to solve this. Or I need to solve x equal 1 over ln, which is belongs to the domain. Domain R Orion. I have no problems here. Okay. Now check f double prime. If you do the calculations, you get this 8 fourths minus x, and then 4 x, and then 4 minus 2. So if double prime, and this is strange number, that will be positive. That will be positive. Here I have what? 1 minus 2, which is minus 1. So that will be negative. So I have local max at x equal to 1 over n4. Okay. Last one with this group, arc secant. We did not do any problem with arc secant. Let us do it. Y equal arc secant x minus x. What will be f prime? F prime will be, yeah, I think I need the calculator. No, I can't. I think, yeah, maybe we need the calculator. But let me try to do it. Okay, that will be 1 over absolute value of x square root x squared minus 1 minus 1. I need to find the critical numbers. I solve this. Yeah, we need the calculator. I have absolute value of x is equal to 1. How to solve this? Square it. I have x squared minus 1 equal to 1. Yeah. So I have x to the power 4 minus x squared minus 1 equal to 0. If I let u equal x squared, that will be u squared minus u minus 0. Minus 1 equal to 0. And this is if you solve it by the quadratic formula. You have what? Minus b plus or minus square root b squared plus 4 over 2. So it's 1 plus. So I need x squared equal this. By the way, I have x squared 1 minus square root of 5 over 2. This is rejected because this is negative. So I have only x squared 1 plus square root of 5 over 2. So x will be plus or minus. This is strange now. Also, we'll do f double prime. I will not. I think we need the calculator at the end. That will be minus 1 over x. Check it yourself. Minus x squared minus 1 to the power 3 over 2 absolute value of x. Yeah. And then check. I think you need the calculator. Can check positive, negative. Okay. Think about it. Sketch the graph of a function having the given characteristics. Now it's the other way. He gave us some information and he wants us to graph the function. Okay. 67. I have f prime positive, so it's increasing. 67. Let me put the information. I have, if you like the numbers, I have 1 making a difference for f prime. 1 before less than 1 is positive, and greater than 1 is negative. So it's increasing, then decreasing. For f double prime, what I have, it's always negative. So it's concave down all the way. Okay, and I have f at 0. This is easy to do. F at 0, 0. F at 2, 0. Okay, and it's increasing before 1. 1 will make a difference. I don't know 1 is what. And I have at 1, I have tangent line. So I have local maximum here. That will do something like this. This is at 1. So this is f of 0 equal 0. F prime is positive, increasing, then decreasing, and this concave down all the way. So this is the function. 69. What I have is 69. You have f of 2 equal f of 4 equals 0, f prime is negative, f prime before 3, it's negative, and after 3, it's positive, and if double prime is always negative. Okay, so it's decreasing and increasing, but there is only one thing: if double prime at 3 does not exist. Okay, so I want to grab the function, satisfying all of these things. I have f of 2, 2 and 4. These are points. And before 3, it's decreasing, so it will do something like this. And it's concave down. By the way, the function is always concave down, so it will do something like this. Up to a value here. Then also concave down, so it will do something like this. So here I have a corner. So this is not f prime at 3 does not exist on vertical tangent. Okay, I have the prime does not exist here at 3, and this is concave down, and this is concave down. Okay, find the cubic functions. Okay, he has two. He gave us A, B, C, D. He wants us to find those, and he gave us some information. A relative maximum this, relative minimum this, inflection point this. Okay, so this is f of x. Since there is f of x, since there's the relative maximum, I need to find f prime. Let me do these things first. F prime will be what? 3ax squared plus 2bx plus c. Also, I need f double prime, which is 6ax plus 2b. Actually, what I need 4 equations. Actually, I have more than that. I have from this, I have f of 3 equals 3, and f prime at 3 equals 0. From this, I have f of 5 equal 1, and f prime at 5 equals 0. From this, I have f of 4 equal 2, and f double prime of 4 at 4 equals 0. This is what I have. So choose some of them to try to solve the equations. Okay. So I have 4 equations for all nodes. Actually, I have more. So choose what is the best. I think I can start from this. That will make it easier. I have f double prime at 4 equal what? 24a plus 2b equals 0. So now we can get easy equation relating a to b. That give me what? B equal minus 12a. Okay. B equal minus 12. That will save a lot. Now I plug f prime at 5 and f prime at 3. I have f prime at 3. We'll use this. I have a and b, so I can get the relation between c and a. Then I can get a and c, then I can get b, then I can get d. Okay, so I have what? F prime at 3. That would be what? 27a. Yeah, but the numbers will be very complicated, it seems to be. Plus 6b plus c. That should be equal to 0. This is from f prime at 3. And f prime at 5. That will be what? 5 squared is 25, so it's 125a plus 25b plus c equals 0. Okay. Yeah, I can do it two ways. I can subtract these two. Second 27 minus 125, that will be what? I can subtract this from this to make it positive. So I have 98. I'm doing 2 minus 1. This is 1, this is 2. I'm doing 2 minus 1. So 98a plus 19b. This is 0, equal to 0. But also I have b equal minus 12a. Yeah, 98a. Here's something wrong. I'm getting nothing from here. No. So that gives me 19.8a. We add them. This plus 16b, not 19, plus 16b equal to 0. That will not help. Why? That means a equal b equal 0. Yeah. Okay, let me do other things. F of 3 equals 3. Maybe this is better. F of 3 equals 3. That give me what? That give me 27a plus 9b plus 3c plus d equals 0. Equal 3, not 0. Okay. F of 5 equals 1. So that implies what? 125a plus 25b plus how many c? Plus 5c plus d equal to 1. Subtract these two. Yeah, that will give me a good one. I have get what? 98a plus 16b plus 2c equal minus 2. In other words, I have 49a plus 8b plus c equal minus 1. This is another equation. Okay. Now, I have also f prime at 3, that one. I can solve this one with this one. Yeah, that will be a good one. This one with this one. Okay. If you subtract them, you get what? 22a plus 2b equal minus 1. Yeah. And I can do this with this one. Now, I have 24a plus 2b equals 0. And subtract, you have 2a equal minus 1. So a equal minus half. So b equals 6. You get a and b. Okay. I plug it here. You get c. You plug it here, you get c. You plug it here, you get D. If you do that, you get C equal 45 over 2, and you get D equals, how will I do the calculation? Minus 24. So you have all of these things. So you can write the function now. It will be f of x will be minus half x cubed minus 6x squared a equal half or minus half. Wait a minute. I subtract this from this, so a equal half, sorry for that. And b equal minus 3. That will be half, and this is minus 6 plus 45 over 2x minus 24. Yeah, this is the idea. And we need now to control the equations. You have 4 or 6 equations actually, but you can deal with 4 of them to control it. I think this is a good idea. You do this, you make it ABC equation, then from f prime, you get another ABC equation. You solve these two, you get AB equation. Also from f double prime, you get AB equation. Now we have two equations, two unknowns. You get A and B. Then you can get C. Then you can get D. Okay. And just to save time. Okay. Now let us go to true or false. Then we have still we have. Okay. True or false equations. The graph of every cubic polynomial has precisely 1 point of inflection. Is that true? True. Why? Let's take 89. I have, this is ax cubed. This is in general an a cubic function. What is y prime? What is y double prime? Which is always have a 0. Yeah. Which is equal to 0 implies x will be minus b over 3a. So you put the value minus b over 3a, you will get change. This will be change of concavity. If this is plus, there'll be minus. If this is minus, then this will be plus. So you have point of inflection. Yes. So this is for sure always will be point of inflection. 90. 90, it says, but the graph of this is concave down from this, concave up this. It has a point of inflection at x equals 0. No, it's not defined at x equals 0. So this is wrong. This is false. If is not continuous. If it's not continuous. X equals 0. 91. If f prime is positive, then f is concave up at x equals c. No, who said that? Yeah. If we take, for example, f of x equal x, we say no, there is no concavity. So f prime will be 2, which is positive at any value, but we know that x has no, but is not concave. Actually has no concavity at all. So this is false. 92. If f double prime equals 0, then the graph must have a point of inflection. No. Example, take this example. Okay, at x equal to, because I said that x equal to. If you notice, f prime will be 4 x minus 2 cubed, but f double prime will be 12 x minus 2 square. Yes, I have 2 when f double prime equal to 0, but there is no change in concavity. There is no change in concavity. Means no inflection point. So this is false. False. Okay. 88. 3 more problems to go. This is 88. He said what? Point of inflection and extrema. Show that the point of inflection of this function lies midway between the relative extrema of f. Okay. It means I need to find the relative extrema and I need to find the point of inflection. F prime will be what? Yeah, this one is what? X minus 12x. So f, not f. Let me do f first. F is what? X cubed minus 12x squared plus 36x. F prime will be 3x squared minus 24x plus 36, which is I can rewrite it as 3x minus 2x minus 6, make it equal to 0, have x equal to or x equals 6. So I have 2, 6. Yeah, before 2, this is positive, negative, positive. So you have relative extrema at x equal to at x equals 6. Okay, now we'll do f double prime. F double prime will be what? F double prime will be 6x minus 24 equal to 0. So I have x equal 4. Okay. And by the way, at a relative extrema, I'd have 2, the point, as a point, it will be 2 and what? 2 minus 6, 4, 16, 32. And 6 and 6 and 0. Inflection point, I have 4 and what? 16. I have 4 and 16. Yeah. What is the mid of these two? The midpoint. I have 2 plus 6 over 2 and 32 plus 0 over 2. That gives me what? 8 over 4 and 16, which is this one. So this is correct. Okay. These last two questions, 93. He said what? F and G are concave up. That means what? 93. F double prime positive and G double prime positive. Okay. Prove that F plus G is also concave up. Okay. Let me take this function, F plus G. What will be H prime? It will be F prime. What will be H prime plus G prime? I need H double prime, which is, this is positive. This is positive. So this is positive. So this is correct. 93 is correct. 94. Actually, we want to show, so it should be all correct. He said what? F positive and G positive. This is the first things. F increasing, that means F prime positive and G prime positive. Concave up, that means F double prime positive and G double prime positive. What they want? We want to show no, if G is also concave up. So we need to find H equal F times G. What will be H prime? H F prime G plus FG prime. What will be H double prime? It will be F double prime G plus F prime G prime plus F prime G prime plus F G double prime. This is positive. 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 So for sure, this is positive. So this is correct. Okay. Now we finish. Hopefully it's will be good ones to practice. So I will stop the recording now.